The Earth's water cycle is a very unique cycle. First off, the water is in the ocean and is evaporated by the sun and turns into condensation. As the condensation builds up in the clouds, it falls down to the earth as precipitation and runs off into the ocean again. Another way this happens is plant intake. It goes into the plants, and then as the plants use it, it turns into condensation again by the sun pulling it out. So this is the Earth's water cycle.
Hi, my name is Carl. I just happened to crawl out of Erica's laptop case and found this cool group talking about Earth's water cycle. I'm here to teach you guys more about why the Earth's water cycle is important. The reason I need it to live is because it supports many forms of life, such as plants, animals, humans, and me, of course.
Why must a planet have a water cycle? The water cycle is important on Earth because it supports many life forms. Rain is important to grass, trees, and natural plants. Grass, trees, and natural plants are important to wild animals. The animals that provide us with food must have water. The greenhouse effect is a natural process that keeps the Earth warm. Without it, the Earth would be unable to retain enough heat to sustain life. The enhanced greenhouse effect is caused by all the extra greenhouse gases, carbon dioxide, methane, etc., that humans put into the air from burning fossil fuels. These all trap heat and radiation from the sun than is normally required and can cause temperature of the globe to rise. How are they different? A greenhouse is a gas shed where fruits and veggies grow and the sun heats the air inside to stay warm. A greenhouse effect means that the atmosphere is being filled up with more greenhouse gases that trap the sun's gases, causing the Earth to slowly become hotter. How does carbon create organic matter? Carbon is very important because it makes up organic matter. By studying the carbon cycle, we can study the flow of energy on Earth. Because most of the chemical energy is needed for life is stored in organic compounds and bonds between carbon atoms and other atoms. Why do living organisms on Earth need a carbon cycle? First of all, carbon is an essential element because it is the basic building block for all life forms on Earth. Secondly, the carbon cycle is important because it moves carbon from the atmosphere and oceans into organisms and back again. Humans, plants, and animals need carbon to live. If the carbon balance is upset, it could have very bad consequences, such as global warming and climate disruption.
Venus and its atmosphere. The atmosphere on Venus is almost completely made of carbon dioxide. There are also small amounts of nitrogen and a thick cover of sulfuric acid clouds surrounding the planet. The clouds are so thick that they prevent visible surface observations on Venus from Earth. Venus's atmosphere is about 96.5% carbon dioxide with virtually no water. There is a difference of 500 degrees Celsius between the surface of Venus and its cloud top. The upper clouds absorb half of the solar radiation received by the planet. Venus and its greenhouse effect. Venus has the most powerful greenhouse effect found in the solar system. Approximately 80% of the incoming solar radiation is reflected back to space by the cloud layer. About 10% is absorbed by the atmosphere. Only 10% of the solar radiation gets through and heats the surface. This means that the thermal radiation emitted by the surface gets trapped by the same atmosphere, which creates a surface temperature of 730 Kelvin. The few reasons we could live on Venus. Number 1. Venus has a similar surface gravity to Earth, which is 0.904 Gs due to similar size and mass. This means that there would barely be any health problems caused from a change in gravity, such as muscle atrophy and bone loss. Venus is relatively close by as well. This would make for easier transportation and communications. The farthest Venus is ever away from Earth is about 261 million kilometers. The reasons we could not live on Venus. Number 1. It is so hot that its surface temperatures could melt lead, which would not bode well for us. 2. Its atmosphere is so thick that it would crush us. 3. There are clouds of sulfuric acid that smell like rotten eggs everywhere. So basically, if you visited Venus, you could not breathe the air, you would be crushed by the atmosphere, and you would burn up on the high surface temperatures. The only possible way we could live on Venus is a long shot. According to Jeffrey A. Landis from NASA, instead of colonizing the surface, we might be able to colonize the Venerian atmosphere. 50 kilometers above Venus's surface, a balloon full of breathable air might be able to sustain a colony. At this altitude, it would not be catastrophic if a tear were to happen in the balloon. It would cause gases to diffuse at normal mixing rates, allowing time to repair the tear. The balloon would stay in the air because breathable gas has the equivalent lifting power on Venus as half of helium's lifting power on Earth, which is 1 kilogram per cubic meter. At that altitude, the temperature would be a more normal 0 to 50 degrees Celsius as well.
Why it is important if Mars had a water cycle. Mars once had water flowing on its surface. Today, it's a frozen desert. Mars may have a multi-million-year water cycle. The hypothesis is that volcanic activity melts ice, releasing floods of water. If Mars had a water cycle, it could support life. Mars, its atmosphere. Mars's atmosphere is 100 times thinner than Earth's. Its atmosphere is mainly made of carbon dioxide, which is 95%, and others include nitrogen, argon, and oxygen. The surface pressure is around 0.7% that of Earth's pressure. Mars's greenhouse effect. First, the sun enters the upper atmosphere. Particular molecules block gamma rays, X-rays, and UV rays. Then the IR blocked by greenhouse gases, which is CO2, H2O, and CH4. The next thing on the list, the remaining sunlight enters the lower atmosphere and surface. Then the sunlight reaches rocks and air that is warmed up by the sunlight. And after that, energy re-radiated is IR. But the IR is blocked from escaping back into space by the greenhouse gases. So this is the greenhouse effect on Mars. How we can live on Mars. Yes, humans can live on Mars. However, we would have to go through an extensive process to prepare the planet before we can actually support life there. Here are the steps. Step 1. Send astronauts to arrive before us who will begin to build spacious living units. If we needed to leave the settlement, we would have to wear Mars suits. So the conditions on Mars itself are not good enough to sustain life. We would have to create living
How
spaces.
are the atmospheres different on Earth, Mars, and Venus? On Earth, it is 78% nitrogen, 21% oxygen, and 1% other. There are 5 layers: the exosphere, the thermosphere, the mesosphere, the stratosphere, and the troposphere. On Mars, it is 2.7% nitrogen, 95% carbon dioxide, and 1.6% argon. It is much cooler than Earth with an average temperature of negative 60 degrees Celsius, and the atmosphere is 100 times thinner than Earth's. On Venus, nitrogen is 3.5%, 96% carbon dioxide, and it with an average temperature of 500 degrees Celsius. The atmosphere pressure is 90 times what Earth's surface is. The winds on Venus, on average, are 224 miles per hour. If you were standing on Venus, you would feel 90 times heavier than what you really are.